We are sitting down with Andrew Carney, who is the PM for the AICC. Now, we've already talked, but it was kind of under like a guise of like secrecy.
Yeah.
And now there's no secrecy.
No secrets.
Serious question. Do you feel like a weight off your shoulders now?
I honestly, I feel energized because we can talk about it. So it was a lot of stress for sure, especially, I mean, for the teams, for the organizers, for everyone involved. And so now it's less of a weight off and more of like a, I don't know, just an intense amount of energy to move forward, right? Like the capabilities that the teams demonstrated during finals, and the fact that those tools are now open source and available, is so massively exciting that I really just I want to get to the next step. I want to start helping see these tools kind of be used in the real world, be used at scale.
We definitely, so we spoke with 4 or 5 teams earlier today, and we had a question for them. What was your approach? What did you find surprising? What made you guys, how did you stand apart? And it was very interesting in the sense that everyone seemed to have a slightly different approach. PPP or MMM, I guess they're MMM now, right?
Or theory.
That's right, theory. They took the approach of all AI for everything and not minimize the amount, but let's try and just go all in on the AI tools. Whereas other people went the route we were thinking, which is like, we'll start with a standard framework that we already work with. We'll add in the fuzzing, and maybe instead of a human in the loop modifying the fuzzers, we'll just have the AI do that and kind of go back and forth between sort of replacing the static analysis piece with the LLMs. And we found it really interesting because we started asking, have you read or have you talked to the other teams how you did these? Because it seems that everyone had a key to how to make each piece work the best.
Yep.
But obviously only one team gets to win the competition. It's been interesting talking to them and seeing what their plans are moving forward. Have you had a chance to talk with them?
Yeah, we've had a chance to talk with some of them. I think one of the interesting things, like thinking about competitions and how we grade performance. When we think about, I don't know, an Olympic sport, and you have someone that is consistently like a medaling kind of athlete in their sport, like their performance is ultimately being measured in one dimension or a very narrow set of dimensions. So if you're the fastest person in the world, you're the fastest person in the world. Like we know what fastest means. We don't know what the best CRS necessarily is. We know we had to have a scoring algorithm for the competition. We prioritized patching. Like, we incentivized things intentionally for the competition. At the same time, because, to your point, of the variety of approaches and the different potential use cases, that what is best is, I think, in the general case, hard to determine. And I think about this sort of megazord CRS that is leveraging the best of each CRS that may be very context dependent. So it's not that you're actually even carving up the CRSs, is that you now have an ensemble of CRSs that are batching or sharing work in where the architecture of that work sharing is actually an additional level of magic. Yeah, exactly. Yeah, so I'm super stoked just to see the teams. I was thinking about like collaborative research I find extremely rewarding, especially when it's had, I mean, like in the CTF world, you have teams that will compete, or the organizers are sort of viewing their adversarial role to the competitors, but then the write-ups come out, right? The competition ends, the write-ups come out, and as an organizer, you get to see how people broke your challenges in ways you did not anticipate. And as a competitor, you get to see how other people broke challenges that you may have solved or attempted in ways that you didn't attempt, or like places you weren't successful, or different ways. And that's what evolves like the CTF space. And so, seeing that at the scale of a DARPA challenge, where we get that collaborative like moment and kind of trend afterwards, that is why I am like so energized, is to see the teams get to dig into their data, get to collaborate with the other teams. Like there's they have this opportunity, right, to collaborate in a big way.
Yeah, it's been so interesting, and like I guess we probably should have started. The purpose of the contest is to make this autonomous system, find bugs, patch them. Like we've talked about it before. I always assumed they'd be like, okay, all of them had this type of thing. You have an orchestrator, you have an identification, you have this. Like they all kind of had the same basic thing, but it was fascinating to hear some of the top teams. It wasn't. I assumed it was like, oh, grab a static code analysis or semgrep or something like that. In one of the teams, there was Theory who said, we absolutely embraced it. We had no static code analysis tool. We had one, but it kind of was junk. And for the Java challenges, it was 100% LLM. And it wasn't, it was embracing kind of the wonkiness of LLM, going, it's going to have the same problems as static code analysis. There's going to be a ton of false positives, and then we're going to have to whittle down, and we're going to have to whittle down, and we're going to have to whittle down. But like, what's so interesting about it is all of it is very approachable. This wasn't like a rocket science contest where it was knowledge outside of like a crazy sphere of engineering. Most of the people talking were not engineers, like by their own admission. They were researchers who then use these tools. And that's been so interesting. It always feels like the AICC is almost an unapproachable challenge. Like you have to be, you can't be a normie.
CTF is unapproachable, right? Or
CTF.
Or really any of these large-scale competitions. You're like, that's the Olympics of what we're doing.
Like the CTF example.
Yeah.
A couple years ago, the DEF CON CTF was Middle Indian.
Yes.
It was an architecture that didn't exist. Clemency.
Uh-huh.
And then there was another one, which was like a 7-bit architecture or 7-byte.
No, that was the same one.
It was the same.
It was 9-byte.
Middle Indian.
It was 9. So immediately, all your like anyone who knows about CTFs starts going, oh, that's not that hard. Wait, I don't have a single IDE or debugger. Nothing works. I have nothing.
So they had to write it on the day.
They had to write it on the day. Where AICC, you start filling out these logic puzzles and go, this is doable and possible.
In Python.
And that's been the coolest thing to see on the teams of this is doable and possible. And that's what's been so cool with the contest is when all the teams said the same thing. When we first heard about it, it was like, I don't know if this is going to work. And every one of them came out from it going, I completely wrote off LLMs as possible of doing this. Yeah. And now that it seems, and this is the question, what problems were the teams facing? Because one of them pointed out kind of an obvious one, which was LLMs are really bad with numbers. So trying to figure out what line numbers to insert the new code chunk was difficult. Like it seems like such an easy problem.
Producing a patch.
Yeah. Producing a patch.
They had the problem, they knew how to fix it, but producing a patch, which is a very specific format, was almost impossible for them. That was interesting.
As you've been talking to the teams, what has been the most like surprising thing? Like, ooh, that was a super weird solve on that one.
So I think if we're thinking about challenges that the teams had, I think in general, it wasn't necessarily any particular I think one of the most common challenges just had to do not with the architecture from sort of component or feature level, but creating a system that was stable and scalable enough to run for tens of hours at a time using tens of thousands of dollars of compute, and them be confident that it won't fall over, because they didn't have any access to their systems while we were running the competition rounds. And that's a level of like, when we think about even very popular and performant kind of tools in this space, they assume that you have a human that is setting things up, like configuring things, interpreting the results, and when things fall over, there's a human there to to kick them back up, right?
Part of the standard operating procedure is, and this guy every hour will
Yep.
go press the power button on the server because we just need it to work.
I mean, even thinking back to like CTF and playing, like when I actually played, it was really incredible to see. We'd do all this prep, we'd write all of these frameworks, and then if something broke during the competition, I forget which year it was, but I think it was one of the years that Samurai took first or second, and we were playing against them, and I was talking to, I think, Dustin afterwards, and he mentioned that their scoring framework had kind of borked itself, and they'd spent a teeny bit of time trying to fix it, and then they were like, nope, we have bodies. Your job now, like your job is now to manually execute this scoring query every 5 minutes, or babysit this script and make sure that it doesn't stop scoring, because they had people, and it was not worth the time to sort of try to actually fix the underlying framework issue.
So I'm going to toss this out there.
Yeah.
One of the chats we had was the patch issue.
Yeah.
And they had gotten it to the point where they could throw a patch across to, I think they were talking about one of the 0 days they found.
Okay.
And they didn't just submit the patch to the maintainer, but they did report the bug. They were like, hey, here's a bug, here's a reproducer, it's a thing.
Yeah.
You make the decision on whether or not this is important enough. But it kind of clicked for me that in some senses, there are problems with that. We already talked about that in the last session we had. But there's an interesting connection I made where traditionally the VR experts or the security experts, they come in and they kick your puppy and they give you a bunch of work to do that requires you now as the engineer to go research it all and figure out how it works and how to fix it. Because the VR folks don't do the patch production piece, and they don't need to understand it all because they can't. They're already kind of a master of all trades in some ways, but they need to know their craft well enough to say what's wrong or how it breaks, but not necessarily how to fix it. It clicked for me that this can actually be the glue between engineers to say, I broke it, I don't know how to fix it. The LLM started the problem, started the job. Here's a patch that ostensibly fixes it. You're that domain expert. Look at the patch and tell me if it's reasonable.
Yeah.
And it clicked for me all at once. I was like, that's powerful.
Yeah.
I wanted to get your take on that.
No, 100%. I think one of the and this is a topic I know will be explored in great depth very shortly, or like in the coming weeks and months. But I think there is a major advantage to having the context of having found the vulnerability and then directly applying all of that state knowledge or program understanding to your development of the patch. Right, the human process, right, when we do this, it's impossible to communicate everything you've learned about an application, especially if you haven't had source code. But even if you have had source code, you think about that application fundamentally differently than the developers, than the maintainers of that project. And so you have unique, helpful knowledge. Communicating it in any kind of effective way is very challenging. So you provide a POC, you maybe give some key points as you can. I mean, maybe you engage with the developer and help revalidate the patch, but it's very labor intensive. You're never actually communicating the whole of your knowledge to them, and they certainly can't communicate the whole of their knowledge to you. With the CRS and with this like closed feedback loop, it's sort of like you're using the same brain to solve both ends of the problem, right? So you know, and I don't know, I'm sure smarter people than me will define exactly how that's useful, but it seems intuitive that it would be, I think, especially from like a general program understanding perspective. And then to see the teams, I think I would be very surprised if that was not a major
Takeaway.
something behind the massive like jump we saw in the team's patching rate. They patched over 60% of the total synthetic vulnerabilities, and then patched produced patches for most of the 0 days they found.
Wow.
And that was a huge leap from semifinals, and we can probably write some of that off as model improvements, but not most of it. I think it was their leveraging of that context. 'Cause you can't shove an entire application into the context window.
Yeah.
They were not taking the naive approach to solving this problem. So I think there's something powerful in that we have all the information that led us to the vulnerability, including all the paths that were not vulnerable or were not an issue or what have you, and we can use that to craft a better patch more quickly, more cheaply, etc.
So contest closed up right now.
Yep.
All the teams have open sourced their things. Have you heard from any of them like what their plans are next on the next iteration of it?
So the teams, I think the best answer to that is asking the teams. I realize you guys have done that. I think it's exciting that none of the teams are looking to stop developing their CRS. There was some concern with the open source requirement that would be a deterrent or reduce the incentive to maintain or update or their effort. And Perry Adams, the founding program manager for AIxCC, she was the one that really made that a core tenet of the program. And when she handed the program off to me, and when we talked about how things might need to change, that was never at issue. Like I was like, oh, that makes perfect sense, right? Like, and I really thought about collaboration and sort of, you know, that's one of the reasons that we felt good about the prizes being as high as they were, is because we're rewarding your performance, but we're going to take that knowledge, take that technology, and it's going to be shared with the world.
So I want to ask the competition as a DARPA program.
Yeah.
I think most people think of DARPA as this super secretive organization that doesn't necessarily work in partnership public-private, even though that's basically what it is, right? But they have this sense of it's all super secretive. This particular program is interesting in the sense that GPT was like LLMs as an attainable thing only really showed up like 2.5 years ago. And then this launches immediately. And I think everyone can easily say the models are kind of like building the plane as you fly it. And so you're one step on top of that where everyone's building on top of models. So you're like building the engineers who can build the plane while you're flying the plane type thing. Is there anything about this process and how fast the technology is moving? I think as an engineer, it is amazing how fast it is moving, and I'm used to things moving fast. Was there anything interesting during the development of the game in that sense where everything was moving so fast underneath? You know, OpenAI is providing new models rapidly.
Yeah, so it definitely. So I've been involved and talked to folks who've been involved in a lot of different DARPA challenges in one way or another. I've never actually competed myself in any of the DARPA challenges, but I followed CGC very closely. Yep. While at DARPA, I definitely work very closely with folks that have worked on almost every DARPA challenge. And part of creating a DARPA challenge is framing a problem, I think, so elegantly and thoughtfully that the problem doesn't change. Like the challenge itself, the goalposts don't have to move because you have created such a high bar for people to hit that you can really spend multiple years developing the intermediate and final kind of contests that take the challenge kind of through its paces. To your point, with AIxCC, we were talking about evaluating the capabilities of technology that was, one, new, and two, advancing very quickly. And that changed how we developed the challenge. The pace of the challenge, we had to do a lot in parallel that normally with DARPA challenges we do in serial. And that, for the competition organizers and the teams, for everyone involved, that made it a lot harder. The timelines for the teams for development were it was not 2 years of development for the teams, because after every iteration, we had to update the rules. We had to review the results, and that took time. If we'd had, you know, AIxCC wouldn't have made sense, I think, as a 4-year competition. I mean, like one couldn't see the future of this technology and benchmarking. Obviously, like that's not going away, but to have the maximum impact and to really like push people to do the most possible, we needed to move very quickly. And so that I'm super grateful for everyone's both patience and kind of like acceptance that this challenge felt very different, I think, than maybe other challenges because of the timelines involved, and the fact that we were chasing this moving target of technology, and even just collaborating with the frontier model companies. You know, we had a very bright line in the sand, and they were so gracious and so helpful. Where, you know, we didn't ask for any inside information on model releases or non-public models. And we kept all the information about what the competitors were doing private. So they had no knowledge of what the teams were kind of doing in that competition itself. They were very helpful when it came to expertise on the models and how they evolved. But they were, you know, I think just as excited to see the semifinal and final results as everyone else, because as close as they'd been to the competition, we had still kept kind of the secret sauce from the teams, very close hold, to keep the competition, for the sanctity, for the sort of stability of the competition. And you know, it's been, so I don't know, it's so many unique elements with AIxCC, but I think they were necessary given the urgency of the problem and the type of technology that we were loosely or loosely coupled to. I will say one follow-up. I actually wish there had been a team that made it to semifinals that didn't use LLMs at all. In semifinals, so that's almost like the null hypothesis version right here.
Yeah.
It's like, okay, given no AI, no LLM usage at all, what can you do? And we had a sort of synthetic virtual benchmark based on existing tools and work that we kept, you know, developing throughout the competition. But in semifinals, we had a number of submissions that basically said we don't need LLMs. Like we're fine. Like we can do this better. And they had other, I'd say, flavors of like classical AI or automation that they were like, this will give us all the leg up we need. None of those teams made it through the semifinal round.
Yeah, just like theory, they were saying like we heavily relied on it. It still blew my mind when they're like, first, we used like this tool. He kind of like wrote it up. We used this one tool for C and Java, but like it was supposed to be for both, but it didn't. It sucked at Java and it was okay at C, so we used it.
Yeah.
But like 2/3 of everything it found like was from the LLM. Like that is, it's still nutty to me hearing that. Like I assumed it flipped. I assumed AI would be really good at patching and terrible at vulnerability detection, and it was the exact opposite. It was really good at vulnerability detection, and it was not great about patching. Like it would do it, but it couldn't do like where it was in the code, or necessarily like these 4 steps fuzzing earlier. We're gonna be able to. It also surprised me that not all the teams did traditional fuzzing. Like some of them just out flat. Like here is the code. Find false positives, start weighting them, and then start narrow it down.
Yeah.
So what's next?
Sleep.
A lot. So DARPA and ARPA-H authorized an additional 1.4 million in prizes for the teams. Every team, all 7 finalists, have the opportunity to get $200,000 in $10,000 increments as they demonstrate the deployment of their CRSs or technology based on their CRSs into actual critical infrastructure relevant code. That can be open source, it can be commercial. So we have an incentive for them to deploy this in a way that makes very like real impact. We're working with the Open Source Security Foundation and the Open Source Technology Improvement Foundation to get these systems out directly to maintainers with kind of in whatever way those maintainers want. It's sort of, we're leveraging the Linux Foundation to make that outreach on our behalf, and we want to meet people where they are and provide them with as many resources in the shape that they would like to receive them, to help kind of
And that seems like it's going to evolve naturally over time because no one knows exactly how they want it yet. And we had a short discussion about that. It seems like, yeah, I am a kernel developer, right? This seems like, yes, I want to do all this testing on my code all the time. Not everyone has a data center to do that, but we know the Googles and the Intels and all these major companies, they do have those resources and they already do these things. There seems to be a natural integration point. It's just how do you keep the noise level down so that the engineers can continue making forward progress, right?
Yeah.
And that, I think we all are interested to see where it goes, but we're all at the same time, a little hesitant to just throw ourselves fully into it. And I think we heard that from the competitors. They were all surprised at how good it was, but it all had the same, we'll say, the classical problems of too many false positives. And so we know that that's going to be a little bit of a struggle.
Yeah, I think one of the interesting, like thinking about the sort of the ensemble of CRSs from finals, the idea that there may be some that are much better at developing POCs or validating POCs, right? Like that each may be better under certain circumstances, such that the harnessless POC generation that maybe theory can do, paired with the validation or patch generation of one of the more dynamic analysis, like that you could actually maybe get to a point where, because I will also say the false positive rates for the teams were the scoreboard does not do justice to, I think, how they're mostly one or two steps away, or one or two additional automation passes away from significantly weeding out a lot of false positives. But there still is this issue of the patch is technically correct, but it is not appropriate to commit to this code base because reasons. It doesn't fit the exact style requirements. Maybe there is a performance impact that we're not testing for. So I there are definitely still, there's more work to do, but I think the I don't know, the promise of having patches in a code base, like I can evaluate a patch for a code base I haven't worked with much a lot more easily than I can write a patch for a code base that I haven't worked with much. And I think, like, if we're going to leverage human effort, as this last mile, that feels a lot better to me if we're starting from a good kind of functionally correct place. And honestly, even, I think one of the teams was talking about in their own internal process, or how like using models, and I think most of the teams did not use, they relied on foundation models and not the sort of thinking models, the reasoning models. And that the foundation models, they could sort of achieve internal consensus by asking the same model the same question, and then some number of times, and then get high confidence in the answer based on the most frequent, however they were binning it. And that was cheaper and faster than using a reasoning model. So I don't know, I think there's interesting more opportunities kind of in that like optimization space that we'll see from the teams too.
Yeah, I think like especially some of the thinking models, I think like things like agents and whatnot, it's like I can write my own for loop is kind of what we heard from the teams. But the full-blown reasoning models where it's like, all right, go and find sources for this that I might not have accounted for, and now don't use those resources. One thing that was really interesting we kept hearing was early days, and this contest has been going 2 years, early days, they had to use all the goofy tactics to get the LLMs to kind of behave. You are a vulnerability researcher. You are a pen test. I think one of the funnest ones I heard were like, you are 100 different engineers solving this problem. If you solve it wrong, and it goes, you solved it wrong, kill that engineer, and then use one of the other ones to solve it. Like all these like weird games, and all of them have said they've matured enough where now it's almost flipping the opposite problem where you don't even have to give it a lot of instruction to get it to do what you want. And if you give it too much instruction, like do this, it's almost like, well, I would have done it the right way, but now that you've told me this way, I'll do something weird.
Yeah, I think Team Atlanta, Tae-Soo Kim was talking about, I think he mentioned that in one of the conversations or interviews, exactly that getting to that right level of specificity was really challenging, like as the models evolved. But they needed more hand-holding earlier, that they needed more. But then Trail of Bits mentioned like that their orchestration was mostly not LLM driven, right?
Yeah.
That their orchestration was mostly like we know the process we want, and we know the criteria for moving through those states. We are using the LLMs as a tool, like a set of resources. But the logic of the system is mostly I'm not gonna say predefined, but like the strategies, the tactics, like we've that looks like something more more familiar.
So I got one last question and we'll wrap it up. Hindsight being 2020, what would you have done differently in making the project? Just one thing.
Just one thing.
Just one
one thing. I think we would have had our evaluation process and the automation that evaluated the competitors would have I would have changed that process so that we could have done more unharnessed challenges. So
okay.
I think harnesses are a super reasonable, useful like approach for testing code, and we have harnesses for so many, highly used popular code bases. We should not throw these resources away.
But it's limiting.
What?
But it's a limiting factor now.
It requires some upfront development. I mean, that and also harness expansion. So the idea that you would have an existing harness, how do I increase the code coverage of that harness? Sometimes if you've solved a problem that might be hard for some automated program or code synthesis flavored solution, so those are research questions that we played with a lot, and we really tabletopped and wargamed and like had proofs of concept for a lot of different ways to allow a wider diversity of approaches. Because that's what the ARPA model is all about. Set a target and be as minimally prescriptive about how you get there as possible.
Very cool.
So I think that would have been what I would have done differently is I would have focused on being even less kind of prescriptive with the mechanics of the competition, so that would have allowed a wider diversity of approaches to shine.
Very cool.
That's great, man. There's so much I want to talk about. I know it sounds like it's going to be such an interesting future, especially with all these teams have open source, and in talking to them, some of them you're able to run in your own home systems.
Trail of Bits, as of yesterday, they released a standalone version of Buttercup, their second place CRS that will run on a laptop, standalone.
And it's those pieces where now everyone can tinker with the existing, and now we can iterate to improve them as opposed to always going from scratch.
Yeah.
That is cool to me.
Very cool.
Thank you so much for your time. Thanks for coming. Thank you for watching. And as always, hack on.